Hi everyone, and this video will be a little bit different and I'm trying a slightly longer version and hope you will like it. In today's video I will show you how we can make our own game mode and create our custom inputs, which is quite interesting, and I want to share this with you all. Happy learning! So what we are going to do in today's video is using this sphere as a pawn object, and we want to control this while we are playing in the editor, right? And for that we will create a own game mode instead of using the third person or the first person templates which are already there. I'll just show you. So third person, first person, and top down, which are already there. Instead of that, we will create our own game mode and apply our own inputs to that. Cool. And first thing is, in the world settings we need to see where we have to set the game mode, right, for this level. So right now the game mode override is none, right? Because we don't have any game mode selected. And the game mode defines the further classes, which are pawn class, hut class, or any controller classes which we are using. So for any game, most of the time the controller class is a separate class and our pawn class is separate. But right now what we are doing is including the inputs in the default pawn only. Okay, cool. So the first thing is to make a new folder. I will make a new game mode in the blueprint class, which is game mode base. You can see this is the game mode where we can define all its rules, scoring, and other type of all other type of game basics. I'll just make this game mode. You can see it here. All these classes are here. What we are interested in is the pawn class. We need to create our own pawn here, right? So we will create another class which will be a pawn class, or a player. I'll just make it player, and I'll make a new blueprint class which will be a pawn. So a pawn is an actor which can be possessed. So we want to possess this character and we want to move and look around, right? So we'll just create this and I'll just name it player one. Cool. And right now it is empty. There's nothing inside this. So we'll just add a static mesh and use that sphere which we were using before. Just turn off engine. Yes, this is the sphere we want to control, right? And I can make this as the default scene route. I don't want a separate route for this. I'll just drag and drop it here. So this static mesh, I'll just rename it to player. So this is our player right now. I'll just save and compile. Save it here. Right now we don't have any game mode override, right? So we will just create our game mode. So the one which we selected was BP game mode, which we made. But you can see the pawn class here, default pawn class is default pawn. We can change it here, but I would love to do it inside the blueprint itself of the game mode base so that everything is settled. So when you don't have any events, graph or anything, it will by default come like this. If you open the full blueprint editor, this will be here. But we don't need this right now. We just need to change our pawn class to DP player 1, and that's it. I have just made it the BP player 1. You can see the default pawn class is BP player 1. So right now if I play it, you can see on the bottom of the screen I can see the sphere which I added, the player which I added in the blueprint. The one you can see in the middle of the screen is this. I just added it static. I will just delete it. So what we need to do to see our character, we need a camera, right? So I'll just add a camera here. The camera should always follow a certain sphere or the player which we are making, it should always follow that, right? Whenever we are moving or looking around, we can move the camera also, but it will not always be connected to the player. So there's a handy note, not note, but a component which we use is a spring arm. Right now, the spring arm is here. We just want the spring arm, no, the camera to be component of the spring arm itself. So whenever we move the spring arm to any length, the camera should move accordingly that. So I'll just move it a little bit back. Our default 300 is fine. I'll just compile, save, and check it in the level. You can see now our player is there, but still I'm not able to move. So for moving purpose, we need another thing which will be a new component which is a floating pawn movement. Right now, this defines simple movement for any pawn class, like looking around, moving, jumping, or anything. You can see the max speed, acceleration, turning boost, and if I compile it and check it here, still not able to move. So for moving, we need a certain inputs. Like when we press W, A, S, or D, we should move, or when we move our mouse, we should look around in the level, right? So for that, we need to create inputs. For our inputs, what we need is to bind the keys to a certain input, right? I'll just create a new folder which will be inputs, and I'll just create a input from input action. So this will be for just looking around. Okay, I will just rename it to IA underscore look, which is just looking around with our mouse. I just made this IA look. It won't be a boolean because the boolean provides either 0 or 1 or like true or false, right? We need to move in minus x and x and plus y and y, right? Plus y and minus y, all the direction. So this x is 2D, vector 2D will be great for us. I'll just save it. Right now, what you can do is if you come to event graph and search for IA look, you'll get it. So this event graph is of our pawn, which is BP player 1. So you will get this enhanced input action. So by default, Unreal Engine uses now enhanced input action, and you can see it here in the inputs. See, axis and action mappings are now depreciated. Please use enhanced input action and input mapping context. So these are the enhanced input. All these settings are here, but we don't want to change anything here. So we'll just close it for now. So right now you can see we have just created an input which is IA look, but we need to set a context for this because right now there's no binding to it. Like this is just an axis 2D, but it doesn't know like it should move when our mouse move or it should look around when the mouse look around. So we need to set this to a mapping. Like we need to map this to a certain input, right? So I'll just create input mapping context, right? So I'll just rename it IMC underscore player one. So this is in context of player one. So I'll just make it, and inside this I'll just add our IA look. So how this IA look works is we need mouse 2D axis, right? Because mouse is moving in X or Y, right? It doesn't go in 3D space. So I'll just create mouse and mouse XY 2D axis, right? I can use this and save it. And in the BB player one, what I can do is use the pawns control, like I can control the pawns pitch and yaw, right? I just add my a underscore look, and I will get two values. Split struct pen. To check this, if we are getting any values while we move the mouse, is just print the string. Use this print string node. Just copy this and paste it here again. So if I move my mouse in X direction, it should give positive X or minus negative X depending on where the mouse is moving, and similarly for the Y, right? So just compile it, go here, play, and check. If I move the mouse, there's nothing right now. So that means our input actions are not working. And why is that? Because this player doesn't know what to do, like which inputs to use, which things to use, because we have set the input action, but we are not calling this IMC player the mapping context which we are using, right? So for this, we need even begin play and just call it here. And we have to set this as a default input, right? So we'll just call, not here, I'll get the controller, right? Cast player controller, right? I'll get the player controller, and as player controller, I will call enhanced input local player subsystem, which is basically the input subsystem which we are using in the project settings, which is this enhanced input. And now I can set the mapping context. Add mapping context. Right. If I just do this and select IMC player one, which is already defined like it should do with mouse X and Y, it should give any values, and compile this. So now this should work. And compile, see, and go to this level and check. See, if I move my mouse, it is giving me some values, and if I move in Y, it is giving me some values also. Cool. Now let's get back to our player one. So this is moving, but right now we are not able to move anything in the editor, right? We are just getting the values. So for that, we need to control this pitch and yaw of the player, right? I'll just delete this, add controller pitch input, and add controller yaw input, right? The pitch is basically in the Y direction, like looking up and down, and yaw is like looking moving on left and right. So I'll just go here and get the triggered value. And our X is left and right? We want to move any move our character when we move in X, like when we move our mouse in X direction, right? So we'll just check this first. If I compile this, go here and play. It's not moving, and that is because we haven't set the player to be able to use the pawn control rotation. That is this. So we have to set, um, we just add this here and put and check, and it was not moving. So now how we can move is using the spring arm. We can use pawn control rotation, and that's it. If I go and look left and right, you can see now my pawn is moving. My player is moving in left and right. But now I want to move it up and down also, right? So now with add a pitch input, which is basically Y. Just make it a little more here. So I compile, save, and go to level and play again. So now you can see I can move left and right, up and down. But up and down is weird because when I'm moving down, it is moving up. And when I'm moving up, it is moving down. So these are total opposites. So we want a opposite of whatever we are providing in the pitch input, right? So in the pitch input, I can actually make a multiply with -1 or negate the value. But I would do that in the context of mappings, right? Because maybe we want to change the mapping context and we supply anything else, like we provide any else key or binding. So whatever binding it is, it will always take it from here, not from the actual player, right? So here there are some modifiers which we can use. So the first modifier will be negate. So negate will basically give you the negative values or the opposite values of whatever you are getting. So we want the negate in y because we are supplying that y input in the pitch value. That's it. And if I play, now you can see I can move up and down, left and right, but I'm still not able to move with W, S, A, and D keys, right? So for that, we need to create more inputs. I'll just go in the input and I'll create another input, an input action. I'll make it IA underscore move. So all our movement component will be here. This is a very interesting thing, like what to put here, like axis 2D or axis 3D or anything. So let's say when you are moving in like left and right or front and backwards, that is fine. We can use axis 2D vector, right? But when we have controls for moving up and down also, which will be like another axis, we will need a third axis, right? Because in X and Y we can move, but in Z to move we will need another axis, right? So for now, I'm using just access 2D, but when your game has something like when your character has something which is moving up and down also, you can provide another keys which will be access 3D. So for now, I'll just provide access 2D. That is it. And now our move context is there. We have to add it in the mapping. So I'll just go to mapping and paste I move here. So right now there are no keys defined. One handy way to do is just click on this, press W, add three more keys, click on this, press S, A, and B for right. Right. So let's get into it. Let's see what are these values giving us first. We'll go inside the blueprint and get enhanced, not enhanced. I'll get IA underscore move, our enhanced input action, right? Which you get. And I will break this vector. X and Y we are getting. So I'll just print the string to X and not in the duration in the X, and same thing for Y. And I'll go here and play. So now if I press W, you can see it's giving me values as a positive one. If I press S, also positive one. Better way to do is decombine struct pen and just use this struct instead of using tool. Compile, see. So right now you can see it's giving me value in X, and if I press S, it's also giving me value in Y, sorry, in X, and similarly with A and D. So every value is in X. We are getting nothing in Y. That is because by default Unreal Engine considers any axis, any forward axis to be X, right? So we have to set some modifiers to particular keys when we move around, right? So when we press W, we should move forward, right? But when we press S, we should move backward, which is opposite to W. Similarly, when we are moving left, we should press A, but when we are moving right, we need to press D, but we should get value of positive in D and negative in A, right? But all the values are also in X, so we need certain values in Y. So because when we press X, we want to move in A or D direction, right? When we are moving in A or D direction, we need to be able to get the values in X axis, right? But in W and S, we need to get in Y axis. So for that, there are a few modifiers. So for W, we know we are getting the value in X. So we can get a modifier which is swizzle input axis values, right? What that do is it will provide the first value in y, and that's it, because the order is set to y, x, and z. Similarly, for the s, we can set the same thing because we want the value in y, right? So you can see y, x, z, z, y, x, x, z, y, and y, z, x. So you can select this or this, doesn't matter, but the first value should be in y, right? But now w and s will always be the same because it will give one value in y. So we need to negate the s value. So we'll just negate another value from it. So now w is 1 in y and s is negative 1 in y, right? For a and d, similar things we will do. We don't, by default, these are providing the values in x, so we don't need to get the swizzle input access. We'll just negate the value of a, right? And save it. And we'll check now our print string, how these values are performing. If I press W, it is giving me 1 in Y, S is negative 1 in Y, A is negative 1 in X, and D is positive 1 in X, right? So that is there. Now we will handle the movement. Right now I can't move it, it's just giving me certain values. So I'll just go to BP player 1, remove this, and split the strip pin. So we know X is left and right. So we'll add an input vector. This parent will be floating pawn movement, right? Or you can just use this floating pawn movement and add input vector, right? That will be there. So right now what we want is to move in the right direction. If I directly give the value of x, let's see what happens here. If I press, you can see it's going in very weird direction. It's not moving in forward, left, or right, anything. So we need to set a certain thing here before we supply this vector to this guy. And how we can do that is get control rotation, and we'll get a right vector to this. Get right vector, right? And we'll multiply this value by our x component. And now we have the right vector to the rotation of the pawn. Just delete this. Now we can add this value to the world vector. And if I compile and check, so now you can see if I press D, it's moving right. If I press A, it is moving to the left. So same thing we can do for W and S keys, which are, I'll just copy this. We need to multiply this Y value. So instead of using this and making our graph a more messy thing, what we can do is directly get these values. You might have seen it if we type our IA move, you get the action events and you get the action values also. So we can get directly these action values from here. So you can see the return value is already here. And now we will get split the struct pen. We'll get not this, we'll just need to multiply it by a forward vector. So I'll just get the control rotation and get forward vector. I'll just multiply this, put it here, and same thing. And we'll check it first in the level. I can look around up and down, left and right. If I press W, it's moving forward. If I press S, it is moving backward. Same thing with B and E. Yeah, that is our input system. And you can see right now if I go here and in, it's get very stuck. It doesn't, and it is very like harsh. It doesn't have any smooth interpolation when I am moving. And there's a very handy thing in the spring arm, which is use camera lag. I'll just use 25 and compile it. See, now if I press W, the camera will lag behind a very little bit the speed which you give, right? This will be a little bit more natural. You can put the values accordingly. That is it for now. And one more thing, which is if you want any up direction to move in the up direction, we will do the similar thing. We'll get the add input vector and multiply the z values. So you have to set the z values in the movement using axis 3D vector and put two more keys and use the swizzle input axis which we used in S and change these values to Z, some values to Z to those particular keys, right? And here in the player you can get an up vector, get up vector. So same thing you can do and add another input for moving an up and down. That's it. Thank you.